Hi everyone, my name is Rongxing. In this section, I'm going to talk about some of the CS50 tools that we use to facilitate students' learning throughout the CS50 journey. So we'll cover the standardized programming environment, some of the tools that help educator to collect students' submission and grade students' submission. So to concretely, we will go through these tools one by one. So first, let's talk about the standardized programming environment. So we all know that at the term start, it's often a very challenging task for students, even for educators, to tell their student to set up their own programming environment so that they can get started with the assignment. It is often time that this part, like configuring their own programming environment, scares off lots of students, and it's really a painful process because we are dealing with different kinds of operating systems, and different operating systems require different software packages in order to run just a hello world program. So historically, right, over the past decade, we've been providing students with standardized programming environment. In the early days, we are offering student on campus with like a shell access. So each student actually has their own terminal access. They can still write code in the terminal user interface. Slowly, gradually, we start utilizing AWS EC2 technology. Once that becomes available, we quickly adopt that so that we'll be able to allow students to actually run their code over the internet, right, and get back a response interactively. There's a time that we actually literally hand students like a virtual machine, like an appliance, what we call the CS50 appliance. The student will be able to download this virtual machine images, installing on their computer, like launching this virtual environment so that everyone's programming environment is the same. But the problem with this approach is this time that students will periodically need to update their programming environments just so it's in sync with the course syllabus or course content. A few years back, there's a company called Cloud9, now it's being acquired by AWS. We quickly also adopt the Cloud9 technology, which is a browser-based interactive programming environment, so integrated programming environment. So students can literally just visit CS50.io and they will be able to access a standardized programming environment right from the browser, and then they can start coding right from there. And the good thing about this browser-based approach is that there's not much hardware requirement for students. All they need is like a reliable internet access and a browser, and they can start doing their hello world problem set. Now we transition to use VS Code. VS Code is a very popularized programming environment for industry programmer as well. So we think this is a good opportunities to switch over, mostly because students can get familiar with the integrated programming environment, VS Code concretely. That way, through the terms and at the end of the semester, right, when they finish CS50, they can naturally transition to actually working in the industry without having to learn a new IDE, or they can quickly familiarize themselves with IDE that's similar to VS Code. And that's basically the overview of the history of how CS50 provide a standardized programming environment to students. And right now, I'm just gonna go a little bit deeper on how we actually make this happen and offer students this standardized IDE. And hopefully, all of you can actually customize your own standardized IDE and offer to your student to suit your classroom needs. And just to mention some of the solutions, like in addition to VS Code, there's a bunch of different kinds of IDE available in the wild, right? There's an Android Studio, mostly for developing Android apps. There's an IntelliJ IDE as well, which is also popular. It's a very popular IDE in the industry. So there's different kinds of IDE. You don't have to really use VS Code in order to teach CS50, but VS Code is just working great for us, so that's why we pick VS Code. There's certainly different kinds of IDE that are best used for a more narrow domain of purposes. In terms of virtualization technology, we use Docker. We like Docker. Docker is kind of like a lightweight virtualization technology compared to the traditional virtual machine technology. And on the server side, there's certainly different kinds of online IDE available to students as well. For example, Cloud9, I previously mentioned. And also there's a Google Colab for more like a data science, machine learning focused content. But we picked GitHub Codespaces. So GitHub Codespaces is essentially a VS Code running in the cloud backed by Linux virtual machine running on Microsoft Azure infrastructure. And this slide is actually also available for you to look at it closely. I have all the notes in the presenter notes as well that you can go through them at your own pace. So first, I'm going to talk about, what GitHub Codespaces is. All the CS50 students nowadays will use GitHub Codespace to do their programming assignment. And the front end of the GitHub Codespaces is actually Visual Studio Code. So Visual Studio Code is an open source online IDE, like an IDE developed by Microsoft. Codespaces is actually the compute environment that are backing the VS Codes. So you can think of when you go visit CS50.dev, when you get into the VS Code programming environment, you're actually remote into a Docker container sitting in the Azure cloud. That's called a Codespace environment. So what does it do? Of course, it comes with all the necessary package and software environment that are required by the CS50 course. We also included other software packages such as Java, Node.js, or R, Ruby as well to suit other needs for different curriculum. We definitely support C and C++. That's the language we teach at the beginning. So you might wonder, how does this GitHub Codespace get provisioned? There's one important piece of the technology here. It's called a Docker file. As I mentioned previously as well, we use Docker as the virtualization technology. And Docker file is kind of like a way for you to customize the running environment. You can think of as provisioning your own operating system for this particular code space. And I will go through them in detail in the next few slides. If you don't know what Dockerfile is, don't worry about it. So it looks like this, right? It's a few lines of code defining what the underlying operating system is. For example, in the following example, I'm going to use Ubuntu version 22.04. And I'm going to also pre-install a bunch of packages that I think the code space would need. So it's kind of like a decorative approach. You can define your operating system in just one file. There's another piece of important technology here. It's called the dev-container.json. This is basically a file as well, describing what kind of compute resources you want this code space to have and what kind of a VS Code extension you want this code space to pre-install. So with the Docker file and the dev-container.json file, you can define your own code space. And in fact, that's how we define the CS50 code space for all of our students. We are essentially writing our own Docker file, writing our own dev-container.json file, and put it in students' repository and launch a code space for students automatically. That way, when students go to CS50.dev, they will get the CS50 code space that has everything they need to complete the course. Students can also use the native VS Code desktop client to perform their work. At the end of the day, it's just a VS Code. It's a VS Code. They don't have to connect to the VS Code, the CS50 code space through the browser. They can also connect to the CS50 code space through the VS Code desktop client. And this is basically what it looks like. When students go to CS50.dev, they will get literally like a login button. They can just one click and it will load a code space for them. We use GitHub for authentication, so all they need is a GitHub account and they can access all the CS50 tools. And optionally, they can also choose to launch the code space through the VS Code desktop client. So now I'm going to explain what's happening underneath the hood and what you can do to create your own code space for your classroom. So to get a code space up and running, so you need a GitHub organization. Again, all the CS52 are mostly built on top of the GitHub infrastructure. So everything is surrounding like GitHub services. So in particular, in order to create a code space, you will want to first have a GitHub organization. And you have to enable code space access for this particular organization. For example, if you go to your own GitHub organization, you go to the setting page, you would just enable for all the members or for specific members or teams accordingly. So once you have that settings done, your organization will have CodeSpace enabled. Of course, there's some building specific and plan specific option you also need to pick, which depends on how you want to pay for the services. And for educators, there's often a free access through the GitHub Classroom that's available to all of the educators that you can also check out yourself. There's a link in the slide as well that you can take a look. So once you have this organization set, in order to launch a CodeSpace, all the CodeSpace needs a repository. Again, repository, it's a GitHub. Basically, it's like a way you can put codes in. Traditionally, you store your code base in a certain repository and on github.com. And all the CodeSpace needs a repository to launch. You can't launch a CodeSpace without having a repository created in the beginning. So in order to create a CodeSpace, you will first have a repository. So I'm going to walk you through how you can do this. So let's say you want to create a new repository. You literally go to your organization, click New. There's a button called New button. So you click that, and then it will bring you to this page. You will give your repository a name. For example, I'm going to name my repository as My CodeSpace for the demo. And I want to make sure it's private for now. And also, it's for good reason, because for your classroom, once you use GitHub Classroom to set up this CodeSpace, you don't want other students to see what the other student is doing for academic honesty reason and for privacy reason. So you want to make sure it is private. Of course, you can set it to public or internal, depends on your needs. I'm going to set it to private for now. So once I have that marked, I can just click Create Repository. Now I have a repository, but there's empty. There's nothing in it. First thing we need to do is we want to create a Docker file. As I mentioned previously, we need a Docker file and a dev container JSON file to create a CodeSpace. Now we're going to create the Docker file. Again, the Docker file will contain these 4 lines of text or strings. The first line defining the underlying operating system we are going to use is Ubuntu. We want to perform some updates. We want to install like Git, Java runtime. We want to install Python runtime as well. And in addition, we also want to pre-install like a Python library called Pillow, which is like an image processing library. That's what we are creating, the underlying operating system image. So let's go back to our repository. Once you've finished creating like a new repository, you will be brought to this page because our repository is empty. So GitHub basically asking you, okay, what would you like to do with this empty repository? If you don't understand Git at all, don't worry about it. You can all do this through the GUI interface. For example, this is what you will be seeing if you are following my instruction. By the way, you don't need to follow me in real time for this workshop. All the slides have detailed instruction in the presenter note as well. So let's say I want to create a new file. You literally can just go to this place, click creating a new file. You click that, it brings you to an editor, like an online text editor. First, because we want to create a Docker file, so we will type Docker file. Remember, it's important that it is case sensitive. So you want to capitalize the D for Delta at the beginning, called Docker file. For the content, you would type the content I mentioned in the slide. You can copy paste or you can type it as well. So we're going to type from Ubuntu latest. Right now, we should pin the version to 22.04 because the later version is now 24.04. Some of the package might not work. But once you have the Docker file content ready, what you want to do is save, right? But in the repository world or in Git's world, save means commit. You want to commit your changes. That's why you should click the button called Commit Changes. You click that. It asks you, okay, would you like to put a message? It automatically put a message for you called Create Docker File, which is nice. That's exactly what we are doing. So I'm going to just go ahead and click Commit Changes here in the dialog box. So I click that. It commits my changes. Now I have a Docker file created in the repository. We need another piece, right? we need the dev container JSON file for CodeSpace to launch a CodeSpace instance. So it looks like this. I'm going to explain what it means. We created the underlying operating system image, but then CodeSpace needs some instruction to launch the CodeSpace. That's what the dev container.json file is for. It's like an instruction to tell GitHub CodeSpace, hey, this user wants to launch a CodeSpace. Here's the instruction. So in this dev container.json, it's very simple. We only put this particular line in the file. We basically tell GitHub CodeSpace, launch a CodeSpace using this Docker file. So when CodeSpace is being launched, it needs to fire out a container because the underlying virtualization technology CodeSpace is using is Docker container. So it needs something to build the image, and that is the Docker file. Again, we go back to the repository. We want to add a new file, so we just click Add File, create new file. So for this time, we're going to create the dev container.json file. Now, there's a different way you can create this file. I'm just going to create this file at the root directory, at the root location, the root level of my repository. So it has to start with the file name has to begin with a period. So remember, type period, like .dev container.json. That's the file name. It has to be named like that. And for the content, again, you can copy paste the content in the slide, or you would type this kind of a JSON object notation, right? So build means when you launch the CodeSpace, please build an image using the file called Docker file. So that's pretty much it about the dev container.json file for now. The file is ready. We also want to commit these changes. So we're going to click Commit Changes again. We click that. We saved. We confirm, right? It brings us back to the repository page. Now I have these two files ready, the dev container.json file and the Docker file. Looks like we are good to go to create a CodeSpace. So here, there's a green button called the Code button. When you have your CodeSpace enabled for your organization, you should be able to see this green button, as long as you have a dev container.json file presented in the repository. GitHub knows that this is a CodeSpace repository. So you're going to click that green button, and you can launch your CodeSpace. So when you click that code button, right now, this is the screenshot I took a few hours ago. It's pretty up to date. GitHub might add new feature in the future, but right now, you should be able to find a CodeSpaces tab under the code button, right? When you click that, you can choose different tab. So I'm going to click the CodeSpace tab, and I'm going to click this Create CodeSpace on Main. That means you want to launch a CodeSpace on the main branch. I won't go into the detail on what that means. Main is the default branch of the repository you just create. You can imagine you can create different branches for your CodeSpace, and then you can launch your CodeSpace for that specific branch. We are only doing this for this main branch here. So I'm going to just click Create CodeSpace on Main. It brings me up to this like a launching place. It would be, usually will tell you, okay, this is like setting up CodeSpace. You just wait. It usually takes a couple minutes, depend on how complex the Docker file you're writing. If you are writing like a very simple Docker file, your CodeSpace will likely be launched in 20, 30 seconds, something like that. So I'm going to just tell you what's happening in this screen right now, because we click Launch CodeSpace. What GitHub is doing right now is, okay, it's now looking the dev container JSON file. Try to build the image. So this is the process of CodeSpace trying to build the image. So once the image is built, we have the image ready, then CodeSpace can launch a container based on this image. And you will be presented by this view as well. So this is basically what you will see after you launch the CodeSpace. This is your view. This is a VS Code. It's just running on the cloud. If you use VS Code before, it should look familiar to you. If you pay attention, you can see that, okay, this CodeSpace already comes with two files. Why? Because this CodeSpace is backed by a repository, and the repository we have been working on called my codespace, and I created this 2 file, and that's why the codespace already loaded with the file. So all the file you are actually dealing with other file on the repository. Now let's quickly demo, right, how we can write a program in VS Code and execute it. There's 2 ways to create a new file. One way is through the GUI. You literally just go to the File Explorer on the left, you right-click, you click New File, right? As if you are using Windows, you can go to Windows, right-click, create a new folder. Same thing. So you create a new file. We want to create a file called hello.py. I'm going to write hello world program. So I type hello.py. And I'm now being brought to the text editor. And you can see the cursors now ready. So we can just type hello world here for this Python program. Simple line, print hello world. And you don't have to save the file. The way we configure the CS50 codespace is, or normally, is it will save automatically. But for this demo, if you see like a file has empty content when you try to run the Python program, just remember to save the file so that when you execute it, it's the up-to-date file you are executing. So in this demo, in the terminal, right, we clearly see that after running this program, we get a hello world back. That means Python runtime is actually ready or installed for this programming environment, and you can actually start writing Python code. Alternatively, if you are more, advanced user, you don't want to use the GUI, you can literally go to terminal and type code space hello.java. It will automatically open or create a file called hello.java for you. If the file is not found at the working directory, you are running this command, it will just automatically create a new file for you. So that's the way I create this hello.java file. I'm going to write the same hello world program again, but in Java. Again, we wrote a hello world program here, and then we try to run it. And as you can see, it also able to print out hello world, which also means the Java runtime is installed. The reason why this programming environment already comes with Python and Java is because we define them, right? In the Docker file, we wrote that we want to install those runtime in the Docker file, and that's why this image already comes with the runtime needed, at least for this demo. There's more. In addition to provisioning the underlying operating system, right? Because we are working in VS Code, and VS Code is known for its extensibility, and the experience is also often customized through the VS Code extension. So for Python, some advanced programmer or normal programmer, when they're trying to go to like a fancy IDE, when they write code, it automatically auto-complete the code for you or even provide code suggestion for you. That's actually provided by a plugin, if you will, like a language support. Similar concept also apply in VS Code, so it's also often achieved through extension. So if you want to have code completion for Python, right, we need something for Python. And I'm just going to demo for how we can like install a Python extension through VS Code's extension marketplace. So you click the extension icon on the left. It brings you to this extension view. You can just search the extension you want to install. I want to install like a Python extension. So I type Python, and often it will give you the first result that has the most download. This one is from Microsoft, looks legit. Let's just install it, right? So I'm gonna install this extension to my programming environment. Once it's done, I go back to my Python code. I'm trying to import the payload library. So if I type from payload import image, I haven't finished typing yet. It's already like suggesting, okay, do you want to import the particular image module or the what, right? So this extension basically provides language support for you. Basically enhance your programming experience. Although we disable this for students for good reason. We want to train their muscle memory at the beginning. Similarly, we can also install like an extension for Java as well, as you can imagine. That will provide other language support capability for Java language as well. So as you can see, you can install more extension to further customize the code space experience. We actually also write our own CS50 extension for our CS50 code space, just so there's some experience we want to provide for the student. For example, style 50, even the AI duck that's integrated to the code space, to the CS50 code space, is all achieved through the VS Code extensions. Let's talk about commit changes. When you are dealing with code space, when you are creating file, when you are modifying file, right? You want the file to persist. Normally, if you work on your local computer, your file is persist on your local hard drive. It's automatically happening locally. But for code space, because we are dealing with a repository, so everything you do within code space is considered changes. And we need to actually persist those changes by basically committing and pushing the changes back to the backend repository. Now, students actually don't need to worry about all this because, again, in CS50 code space, we have another extension called GitHub that literally doing the commit and pushing changes every 30 seconds for students as a way to synchronize, as a way to back up their file. I'm just going to explain why we are doing this so that you know what's actually happened underneath the hood of the CS50 code space. So here, because we created like the hello.java file and then the hello.py file, I also modified the Docker file somehow. So these are the changes that the VS Code is telling, hey, you have these changes. Do you want to commit these changes? And I would like to commit the changes. So I click commit. And I need to push these changes back to the repository. Again, everything right now is still happening inside this code space, and code space is just an instance, right? So if this code space is being deleted or destroyed, all the uncommitted changes could be lost. So we don't want that. We actually want to persist the changes back to our backend repository. So I'm going to click sync changes and click OK. It will just push all the changes back to the repository. If you go to your repository view, you will see the two files we just created, right, from the code space. Okay, now I'm going to dive a little bit deeper on how you can further play with this dev container.json. Again, you can go as complex as you want to suit your teaching needs. Here, I'm just going to do a slight modification. Previously, we wrote our own Docker file and then let dev container, let GitHub Codespace to build that image while launching the Codespace. But actually, you don't have to build the image every time you launch a Codespace. You can use the image being built by third party. For example, the Python organization already have a Python image built remotely in the cloud. You can just reference it and use it. That way, in your dev container JSON file, right, you don't have to specify like a build property. You will instead replace it with like an image property. Okay, for this code space, when you launch, you're just gonna grab this Docker image from the Python Docker repo. Get that, use that as the underlying operating system image. And as you can see further down, you see the customization field, which means in this dev container.json file, you can further customize the behavior of VS Code, what extension you want this VS Code to pre-install, what kind of settings do you want this VS Code to have. That way you can customize the theme, customize the font size, customize whether you want to provide students with IntelliSense, meaning do you want to give students the ability to use code completion. In CS50 scenario, we disable that through this dev container.json settings. And you can tinker with this setting however you want, as long as you follow the instruction, as long as you follow the dev container.json guideline, right? So I'm gonna actually update the dev container.json file for now. Again, to update this dev container.json file, you go to your repository view, you click dev container.json, and then I'm gonna add it in place. So I'm gonna click edit, right? I'm in edit mode in this GUI text editor. I can just copy paste the content I mentioned. First of all, I replace build with image property. In fact, this is already a valid dev-container.json file. If you're going to launch a code space using this dev-container.json, it will work. It will just launch a code space with the bare minimum of like Python runtime, like a Python container. But we want to further customize it. That's why we add more things to this container.json file. So we add customization, right, for VS Code. We also want to pre-install some feature that offered by dev-container.json. Again, we need to commit these changes back to the repository. Now the repository has the updated JSON file. What are we going to do? So we want to also launch a new code space. The current code space will stay as it is because it won't automatically update the code space for you when you update the dev-container.json file. Again, each code space is backed by a repository. So we want to launch a separate code space using the latest dev-container.json file. So again, go to the code tab, click launch, and then you can click like create another code space on main, like a plus button here, right? So I'm going to click that. It creates another code space for me. Now this time it looks a little bit different, right? It looks kind of yellowish. This is as expected because in the code space customization, I specify use the theme Solarize Light. This is what the theme looks. And when you launch a code space using that particular dev-container.json file, you will get a code space as you wish, right? Because you define it to use this theme by default. This is actually a way for me to quickly show you that this new code space is actually launched using the latest dev-container.json file. And again, we can quickly verify that it does have the Python runtime ready because we are using the Python image. And this is the current stable release version as well. And again, because in the dev-container.json file, I already specified that I want it to have the Python extension pre-installed. It already comes with the Python extension. That way, you don't need to manually go and install the extension every time you launch a code space. You can literally just define everything you need in that dev-container.json file or a recipe, if you will. You write everything there, you define it, and then you run it. And then you will have a code space that exactly has those settings. And that's exactly what CS50.dev is doing underneath the hood. This complication, we don't want students to actually know what's happening underneath the hood. We just automate the process for the student. And you are actually seeing how this is being done manually. We can also verify that the feature called the GitHub command line features already pre-installed as well through the feature property. Now, you might wonder, okay, this is actually kind of inconvenient. Every time you update some config, you need to launch a new code space. Can we do that without actually launching a new code space? In fact, you could. There's a thing called rebuild code space as a way to update your code space. Let's say we don't want to use the Python image anymore. We want to switch to Java because I have a Java course to teach. What you need to do is to modify your existing dev-container.json file, right, to use the Java runtime image. You also want to switch the Python extension to the Java extension because it doesn't make sense to use like a Python extension for Java program. I also want to change the theme to dark theme. If I do that, let's say I go to the code space, I live edit the dev-container.json file here. This is the old dev-container.json file, still using the Python runtime. Let's change it to the Java runtime, and then change the extension to Java, and then change the theme to dark. Once you save the changes, code space immediately notify you, hey, you make some changes to the dev container configuration. Would you want to rebuild? Rebuild means, would you want GitHub to apply the new updated settings for the code space? So yes, we want to apply these new settings. So we'll just click rebuild. And then you can click rebuild or full rebuild. Detailed explanation on what the difference is also in the notes. So I'm just going to rebuild. Rebuild means, okay, GitHub is now launching a new container using the updated configuration. And now you can see that the new code space actually switched to dark mode, and it has the Java runtime installed. It also has the Java extension installed. So that's basically a quick overview on how you can, create a code space, customize a code space for your classroom need. Again, CS50 is doing exactly similar thing, but we are doing it through GitHub API. We wrote our own web app to automate this entire process for students. So all students need is one-click login, and they will have a CS50 code space ready for them. But if you don't want to use CS50 code space, you want to use something else, that's the steps you might need to go through to provision a code space for your classroom. There are also more additional resources in the slide as well. Okay, that's a lot. We finished get through the first two, so I'm going to talk about the rest of the two quickly. So now that students have the standardized programming environment, they can start writing code. What's next? They need to submit, right? And then as an educator or teacher, you want to grade them. Now we are talking about what tool CS50 available provided to student and teacher so that they can submit their code and then teacher can grade their submission. And all of the tools and how the usage of the tools are available at this URL called cs50.reader.io. The first tool I'm going to briefly mention is called Check50. So Check50 is a command line tool for running automated tests on students' codes. It's mostly for correctness test. So students write some code, they follow like a specification, they implemented it. How do we know if the student actually meet the requirement? So they can run Check50 for a particular problem set. Let's say the student is working on PSET week 6, DNA problem set. The student can actually run this command right within their CS50 code space to know how well they're doing with their current problem set, right? They run Check50, they get back like a live feedback in the terminal telling, okay, your DNA.py seems to be looking good, but it doesn't pass the first check. Then the student can actually look into, okay, correct that code a little bit, modify that code a little bit, rerun Check50 again to see if they can pass auto check. So this is kind of like a tool we provide to students to help their learning. That way, if they can pass auto check, they know for sure they pass, their implementation meet all the requirements. We are also running this in the cloud. So when students run Check50, what's happened is we auto commit their code to a repository that's owned by us. We then have a grading cluster that automatically downloads students' code and run the correctness check in the cluster, and then we send back the result to the terminal. So again, this is all maintained and managed by us and offer free to students to use. For example, in code space, this is what the student will be looking at actually. So the student write their code right in the VS Code text editor. They write their DNA.py, they finish writing the code, they're going to run Check50. And that's Check50 and then space cs50/problem/2024/x/DNA. I'm going to explain what that is in a later slides. But that's the command they will need to run. And we actually provide all the command they need to run in order to run the correctness check. We also provide like a web view for their correctness check result. They can also go to a URL that automatically generated for each Check50 run. They can just go see their result there as well. Alternatively, they can also run it locally. That way, they don't need to send the code to our grading cluster. They can just run it in their environment locally. This is a scenario that happened that when a student doesn't have a reliable internet access, they don't have a way to access the CS50 code space. We actually provide offline version for the CS50 code space, so they can actually run Check50 in an offline way, sort of. That way, they don't need like an internet connection. All they need is the Check50 auto grading code, and then it will run the check within their machine or within their compute environment locally. But they do need to install the Check50 library as well. So to summarize, right, what Check50 does is automated testing. a standardized test case, so everyone running the same chat50 command will actually get their code graded the same way. You get immediate response in the terminal, right in the terminal, what your program did right, what your program didn't do right. Occasionally, in the chat50, we actually provide hints. So if you run into some error, we do have a customized error message provided to student, so the student might know or might get the aha moment, okay, maybe something they should need to fix, and then hopefully they can pass the check. Although passing the chat50 check is not the goal of learning, it's just a tool we offer for them. They should not be like relying chat50 to do their learning, right? We understand that sometimes students just want to get past all the grade and then they keep running chat50. That's something to be mindful of. And so what's the role GitHub play in this chat50 situation? So again, when you run chat50 in the online version, right, we actually automatically commit their code to our repository. All the online students, all the students using this chat50 will have their own repository storing all their code. And that's what GitHub's role is played here. Again, it's for storing students' code. Okay, so what does this command mean exactly? And how you can actually write your own chat50 checks. So in the universe of chat50 and submit50, there's a thing called submission slug. You can think of it as an identifier that identifies a particular problem set. And again, this is an infrastructure or an experience we built on top of GitHub, so it actually has some meaning. The first half, CS50/problem, represent the GitHub repository. So we are actually using GitHub repositories to store all the chat50 checks. That way, all the educator, all the people using chat50 can use that chat50 check to check against their code. The second part, right, there's a branch. You have lots of problem set, but you want to organize them by branch, meaning by different year. It could be by course, right? That's up to you how you want to categorize the chat50 checks you're writing. So we are using branch as a way to categorize or group checks. And then, okay, within that particular group or category, what kind of a problem set this check belongs to? There's a folder called a DNA. And again, if I show you what it looks like in the repository, it looks like this. So this is actually a public available repository. So if you go to github.com/CS50/problem, this is actually the repository that hosts all the checks we use for CS50s in the past year to date. So as you can see, you need a repository, which is the problems repository under the CS50 organization. In your case, it will be your own personal account, and then you create a repository, and then you store all the checks there. And you notice here there's a branch, right? We call it 2024/X. This is for the edX course or for the CS50X course in general. So in that particular branch, we have problems, lots of different problems for different weeks. And then for week 6, we have DNA problem set, and that's how it's being structured in the repository. And if you look at the repository, this is all the file necessary for chat50 to run. And I will explain what it means. Okay, you would want to know how to write your own checks. First of all, if you are adopting CS50, if you are teaching CS50, you can already use our chat50 checks automatically. You don't need to do anything, right? You can just use the check we pre-written without any changes. But sometimes you want to modify the check. You want to write some new checks for your classroom. We do allow educators to do that. To achieve it, you will need 2 files in the chat50 folder, on the chat50 check folder. So the first file is called the .cs50.yaml file. It's like a configuration file that chat50 would understand. This is just our rule of writing this configuration, so you just need to follow the rule we specify. Again, if you don't understand how to actually write this YAML file, there's a detailed instruction in cs50.reader.io available for you. So I'm just gonna quickly go through what this YAML file is doing, right? So it defines we want to exclude everything. First, basically we don't want to collect everything that the student has in their code space or in their folder while working on their problem, right? We only need the dna.py for this particular example, for this DNA problem set. That's the file we care. That's a file Chat50 care. You might want other file to be collected, so you can define them in this YAML file. You want to collect more file, that's fine. Once you have this defined, you also need to write the actual check. So to write the actual check, you will put it in the init.py file, and then you will just write your Chat50 check by following our instruction for all the test case. For example, I'm writing a very simple input-output test here. This is just a declaration function that we require you to write, meaning the following function is a test case. So once you have that written, you can also specify, okay, what this test case is actually doing. So the student, when student run Chat50, they will see the feedback and they will see what this check is actually doing. And this is the actual check. The code will be executed when running Chat50. This is actually a C program the student expect to write. It's a C program, right? All it needs to do is it takes an input called Waddle, and then you just output and the exact same input as Waddle as well. So we are looking for that. We are expecting an input from student's code, so we call std standard in. Basically, we are now sending Waddle to student's code. So if the student code doesn't even take input, it will fail the check automatically. If the student does take standard in, then we want to check if the output actually matches the expected output. In this case, we expect it to output the same thing we send in. So if it passed this check as well, the program should exit gracefully with a status code 0, right? That's the thing we require student to do, at least for this check. So if everything is in order, the student should pass this check. And this is an example of how you can write Chat50 check for a problem set. So again, you have some level of flexibility here. So you can even bring in the dependencies you want to use. You just need to define them in the Chat50 check configuration file. And the underlying environment that you are running Chat50 should have those dependencies. So if you are running Chat50 locally in your machine, you want to write check for Java program. I believe most of the Java dependency we have in the cloud version, but if you have some other typical dependency that you need to facilitate your check, then you need to have those dependencies installed in your environment. And Chat50 will be able to handle that as well. Again, if you are unsure or this is too much, right, you can still refer to the documentation to see how to actually write Chat50 checks. Another tool I want to talk about is called Style50. We do, when grading students' work, we grade them in correctness. We also grade them in the style axis. So we want to know if they are writing code in a formatted way. So let's say I have a Python code, right? But for example, this particular Python code indentation is not correct. Sometimes it has a one-tab indentation, but for this code here, it has like a two-tab indentation. Versus here, it is only one tab. So this is considered not a good style, right? Your style should be consistent. And that's actually the requirement we require. The requirement we provide to students, like they should write a code with good format and readable. And so we wrote a tool called Style50 that basically check the style and show what improvements students need to do to improve their code formatting or style in general. So when you click Style50 in the VS Code top right, if your code doesn't look good, it will show you, okay, on the left is the code you're writing. On the right is the code we think, or the formatter think it should be formatted properly. So here, a student will be able to see, I should erase the extra tab. I should make that changes to make my code look good. In fact, for like indentation is a thing for Python program, right? But for C program, you don't need any indentation. You can write however you want. You can even write like a complex 1 line, 1,000 character program. That's fine, but no one's gonna understand what you're writing. So we want to promote, good style in writing code. But again, there's a different view, right? We also have this different view on a narrow window. We also provide students like a different deep view so the student can clearly see what changes they need to make. If the students still don't understand what it means, because sometimes it could be confusing, by utilizing AI, we were able to integrate our CS50 doc into the code space. So when they click explain changes, they will get back a human readable or plain text response from the GPT-4 to explain what changes you need to make to improve your code. This is all achieved through VS Code extensions. Again, this is just to highlight the extensibility of VS Code, but that's the tool we are providing for students. This is style 50 in particular. Okay, now that the student finished writing their code, finished formatting their code, they want to submit. How are they going to submit this code? One way we offer to all the students in the CS50 online ecosystem is they can use a tool called Submit50 to submit their assignment to us. Again, similar to Chat50, essentially. What Submit50 does is it automatically commits the file or push the student's assignment to a repository, again, managed by us, but student can also access that repository. So it's just gonna push the code within that particular folder that has the problem set file to their remote repository. Again, the command is similar. This time is submit50 cs50/problem/2024/x/DNA. So we are asking students to submit the DNA problem set for the 2024 CS50X course. So once the student execute that in the command line, it will ask you, okay, these are the files that will be submitted. If you have more file that wasn't specified in the configuration file I previously mentioned, those files will be ignored. We only care about what the problems actually need. It will also prompt students, do you mind the academic honesty? Are you sure you want to submit? Because once you submit this file to us, we will assume this is the file written by you. If it's written by someone else, you are clearly violating academic honesty policy. So we do prompt students every time they run this command. They have to either provide yes or no. So if I provide yes, I did write the code, I think, right? So I type yes. And I will submit the code to a repository that actually named like me50/my GitHub username. It will be submitted to this particular repository. And in fact, when a student joins CS50X or CS50 course online, we will automatically provision everything that the student needs, including creating this particular repository. And as you can see, if I go to my student repository, I will see that I submitted the DNA file here. And if you pay attention, I also run Chat50 previously, so it actually has a commit message says automated commit by Chat50, because every time you run Chat50, you're actually also committing file, but you are not submitting file. So we are not going to grade your Chat50 run as a submission. Only when you run Submit50 do we actually count that as a submission. So what happened is, after you run Submit50, essentially you push the code to this repository. We use GitHub webhook. We basically notify our grading cluster by telling the grading cluster, hey, this student submits some file. Go check it. So the grading cluster will basically go in and grab the student's submitted file, run Chat50 again remotely, and then send back the response to our database. That's how we complete the auto grading for the submission. And the question naturally land to, okay, where do students actually see the submission? Because the GitHub repository shouldn't be something the student interact with frequently. So we actually had an application for student and teachers called submit.cs50.io. You can think of it as a learning management system like Canvas. It's just something we wrote for our CS50 workflow. You don't have to use it, but we provide this for you. So student can see all their submission through submit.csv.io. And teacher can also see the submission from their student on submit.csv.io. So as a teacher, right, you are now concerning, okay, then how can I create a course for my student in the CS50 universe? To do that, you go to submit.csv.io/courses/new. You will be presented by this page. In this demo, I'm just going to create a course called Workshop 2024. Once you type the name, you click Create. It takes some time. What's happening is we also automate the process of creating some GitHub themes underneath the hood as a way to represent a course in the CS50. Again, everything is built on top of GitHub's GitHub's infrastructure. So once you finish creating a course, you will be brought to this settings page. You can further customize, okay, how do you want to name the course or any description for the course you want to provide. The most important piece is you want to get your student enrolled to the course, right? So there's an invite link. You can copy paste this link to the email or to somewhere, and then so that all your students can go there and join your course on CS50. That's how you get students enrolled to your course. That's actually the same thing we are doing for all the CS50X course. Once you get the student enrolled, now let's take a look what's happening when students actually click the invite link. So, for example, I'm a student, right? I'm joining the workshop taught by the rubber duck. That's the teacher. That's the main instructor for this course. So this is what I'm seeing. I agree to join the course, meaning the teacher will be able to access everything I submit. And now the part is, okay, what kind of assignment you want to collect? Again, I previously mentioned the submission slug is an important piece in working with the CS50 ecosystem. Okay, I only want to collect this particular DNA problem set for this course. So if student working on other problem set using different submission slug, it won't show up in your submission because you are not collecting those. But if you want, you can add more here. You can also use a prefix. For example, if you want to collect everything that CS50 offer, you can just write CS50/problems/, then everything that matches that branch prefix will be collected if student ever submitted those problem set. And again, you can also invite other teacher or GitHub user to be your course teacher. It could be your teaching assistant, course assistant, so that's up to you. So you can create an invite link and send to your TA. Each invite link only work once. So if you want to invite 5 TA, you will want to create 5 invite links for security reason. So let's say my course, the rubber duck course, has 3 students. They use the invite link to join the course. We now have these 3 amazing students. And they submitted the DNA problem set, right? It looks good. I feel like they already do a good job with their style. They're all getting almost a perfect grade on the style. But one student seemed to having issue with the chat50, with the correctness check. So you will want to see, okay, what happened to that particular submission, right? So in fact, you can actually go and click the chat50, right, to see what's happened to their code as a way to find out, okay, maybe some things students need to improve. So I click on that. I see that, okay, this is what's happening. The correctness check is expecting a bob output for the first check. But this student actually went above and beyond. They give you what is actually happening in its code and also provide the actual output. So the student actually doing a good job, but it's not passing the autograder. That's fine. That's the reality of correctness check because it's not AI, right? It doesn't know how to account for this scenario. But maybe something that you can actually customize your chat50 check to accommodate this particular output to mark it as a correct answer. But anyway, this is how you can also access the chat50 result for a particular student. We also have another tool called the Compare50. It's mostly to determine code similarity. You can use it to resolve some academic honesty cases when using this tool. So if you collect all the submissions from the submit.csv.io, you can run Compare50 on all the submissions, and then it will tell you what submissions are similar to the other submission by a score, right? And then you can zoom in and narrow down, okay, these two submissions that look very similar. You are curious of what's happening, and you want to take some action against it. That's up to you, but this is a tool we also provide you to perform similarity check. So yeah, that basically, yeah, okay, again, sorry. This is what it looks like, right? If you want to see like a side-by-side comparison view, Compare 50 will give you that view to see, gee, like these two submissions are identical. What happened? I don't know. So so as an educator, you might want to investigate this. It could be an academic honesty case, right? So anyway, Compare 50 is a tool to allow you to perform code similarity checks, and it's up to you how you want to deal with the result it presents to you. Okay, that's a lot. We go through all the tool for the Submit 50. For the CS50 tool for grading and submitting and programming. I want to close this by showing you this picture. It's like drinking from a fire hose. If that's the case, I'm sorry about that because it's too much. I also understand it's a lot of material, but the slides I provide should have all the external resources you need to look at it in your own time. Oh, yeah, although I do have one more thing to explain. So besides all the tools I talked to you, we actually have a tool called the CS50.ai. It's an attempt to use AI in our education to assist students learning. So in fact, if you go to CS50.ai, right, this is like a virtual tutor we provide to students for free. Behind the scenes is using OpenAI GPT-4. We want to provide students like a 24/7 teaching assistant. So if the student go to this web page, right, they will be presented with this view. And in fact, I can talk to this duck as let's say, hey, I'm doing a live demo on you, the CS50 duck, in front of some amazing educators across the globe. Can you just say hello quickly? So yeah, the tool will be able to quickly generate like a response. I'm just demoing here by having it say hi to you all. But as you can imagine, students can actually go to this tool as well to ask questions and to get like immediate feedback to assist their learning. Okay, that's all I cover in this section, and I'm open to all the questions. And again, it's a lot, and if you want to know more, you can just look at the slide and the presenter notes. I have all the detailed instructions written there.